All right, so for problem number 9, it says two identical point charges are fixed at a fixed distance of point. By what factor of magnitude of the electric force between them change if? Okay, so let's start with this. This is Q1. The distance between Q1 and Q2 is R. So they're fixed. They're not moving at all. And they want to know what the forces are, and then they give us a series of scenarios. So for part A, if Q1 is twice its charge, so we would say 2 times Q1, and then Q2 is 1/2 Q2. Part B says, how would this affect their original charge or their force? So then the part B says, if both of them were halved, so it'd be 1/2 times Q1 and 1/2 times Q2. And then part C says, what would be their force for part C if one was charged half and the other was left alone? So that would be like 1/2 Q1 and 1 Q2. And so the force is Coulomb's law. All right, so Coulomb's law is this. The force between these two particles is equal to the constant K times Q1, charge 1, times charge 2, all over the radius between the two, or the distance between the two, squared. All right, now this is proportional to Q1, Q2. In fact, you could write it a different way. You could say that Fe is equal to K over R squared times the quantity Q1. Where did I put that?
I don't know.
I there. Q sub 1, Q sub 2. Okay? And so what they're saying is if I change the values of charge 1 and charge 2, how does this affect the overall force? Well, this one, for part A, it says if you double the first and halve the second one, how does it change the overall magnitude? Well, that's easy. It's just going to be 2 times 1/2. Right?
So what's K over?
So that's just 1. So that doesn't change it at all.
What?
Well, it's like 1 times...
Well, the magnitude, yeah.
The magnitude doesn't change at all. It's the same. Because I double one and I halve the other. So I guess to show it quantitatively, what you would see is, all right, so I've got this, but now I'm going to say K over R squared, and then I'm going to put a 2 in here, K1, and then 1/2 times Q2. And so everything remains the same except for this. The only thing that changes is we're multiplying that. So it's the same as saying
2 times 1/2 times 1.
Q1, Q2 times 2 times 1/2. Does that make sense to you guys? So the magnitude is just this part right here that changes.
Mm-hmm.
So now the next one would just be 1/2. Oops, getting a little sloppy there with the handwriting. Times 1/2, which is equal to 1/4 times whatever the original force would have been. And then the next one will be 1/2 times 1, which would be equal to 1/2 times whatever the original force is. So when I want to charge something to serve a purpose, if I were designing something and I needed to manipulate the charges, I might have to figure this out this way. In other words, if I want the charge to be 1/4 of what it currently is, how might I do that without it? But I can't change the radius or distance between them. Does that make sense? And I'm specifically, purposefully using the word radius because I want you to think of the distance between them as a radius because they generate an electric field. So are there any questions on this one? Can I move on to the next one?
Mm-hmm.
We're out.